So in this question, we have a graph. So we'll start right off with our Oizerga. Our origin 0, 0 is there. Our y-axis is velocity, x-axis time. The intercepts, there are two different curves, and they both have positive y-intercepts. We can read velocity time. The gradient is delta v over delta t, which is the acceleration. And the area is v times delta t, which is the displacement, delta x. And so we look at cart x. We see a constant velocity. Then the velocity changes, so there's acceleration, and then it hits a new constant velocity. Cart y similarly has a constant velocity, accelerates to a new velocity, and remains at that velocity. So we know we have a cart x traveling in a positive direction. So let's draw this. Positive direction, negative direction. Cart y travels in the positive direction, which makes sense. Both of them have positive velocities. And reading off the graph, we can see that cart x has 0.25 meters per second. And we might say that cart y has about 0.04 meters per second. We can read that right off, those values right off the graph, 0.04 and 0.25. Carts collide, which would make sense. X is going more quickly. About the cart's velocities is a function of time. The masses of both objects are known. The masses are known. Which of the following how the student should use the graph to determine whether the collision elastic or inelastic and provide a correct justification? Well, if it's elastic or inelastic, it's going to be a kinetic energy. So does the kinetic energy equal the final kinetic energy? And to do that, we're going to have 1/2 mv squared plus 1/2 mv squared. And is that going to equal 1/2 mv1 prime squared plus 1/2 mv2 prime squared? So what do we need? Well, we're told the masses are known, so all we need is the velocity. So now we look at this using the known mass and known velocity. All right, so that looks true because the kinetic energy changes in an inelastic collision. So that looks like it's the right answer. Using the known mass and known velocity, determine where the momentum. Well, that's going to tell us nothing about whether it's elastic. We know the momentum will be conserved. For the next one, using the known mass and known velocity, determine the change in momentum. Again, for the same reason, the change in momenta should be equal and opposite to each other. We know that's going to apply. And lastly, known mass and known velocity, the average force. Well, whether something's elastic or inelastic depends only on the energy, kinetic energy, and that's why it's choice A.